by itself. They can be solved, just like our learning goal says, algebraically rather than by graphing. Doesn't mean they still can't be solved by graphing. It just means there's another way to solve them also, and we could do it algebraically. So we're still solving by substitution. I don't want you to think we're learning a whole new thing here. We're just saying when we solve by substitution and both of the equations are solved for y, what kind of a process should we use then? Okay. So here's the steps we're going to follow. Set the expressions that have the x in. So in other words, we have y equals our mx plus b. Set those expressions that the x is in. Each of them is going to have their own expression. Y equals the expression mx plus b. Each of them is going to have their own. They have x's in them. Set those equal to each other. So in other words, kind of what we're going to do is we're going to ditch the y's. We're going to ditch the y's and set those two expressions equal to each other. Then we're going to solve that equation for x. So today you will always be solving for x first. Then you'll use either equation. Doesn't matter which one you use, because they're both y equals, and you're solving for y. So it doesn't matter. In fact, pick the one that's easiest. Look at them and say, you know what, you look easier than the other one. I'm going to use you to put my x value in and solve for y. And then write the final solution as what? No, you guys know how we write our x and our y value. As an ordered pair. Write it as an ordered pair. Okay. So write the final solution as an ordered pair, just like we do in the other ones. Okay, here's our one that we're going to practice, and then the other one we're going to do is we're going to learn how to set up our own system of equations, and they'll be in slope-intercept form, so we'll get another practice there. So we have two equations here in slope-intercept form. Step A says, take the two expressions that have the x's in and set them equal to each other. So we're going to set 2x plus 5 equal to the x plus 3. Because they're both equal to y. And there's only one y value for this problem. There's only one y solution. So since they're both equal to y, that means they're both equal to each other. Okay, and now this looks like what we were doing in the warm-up. What should we make our first step? Anybody want to offer up a good first step to make here, or a good first move that you want us to make, Ariel?
Subtract 1x.
Okay, subtract an x from each side. We don't have any subtraction to change in this one, so we can go right to subtracting an x from both sides. We could subtract 2x from both sides, but you just make a choice. You just got to start. This is probably a best choice. So 2x take away an x. What do we have on that side now? Isaac, what's
1x.
That's a 1x. So I'm just going to write it as x. Bring down my plus 5, my equal sign, and what's the right side now? 3. Okay, go ahead and finish solving that for x. Show the work. You know how to do it. And see if you agree with me. Okay. Everybody feeling pretty good about this answer? Okay. Well, now, step B says, now that you've solved for x, now you're going to put that into either equation, it doesn't matter which one, and solve for y. Now remember what I said. Typically what you want to do is you want to be like a good math thinker and say, you know what, which equation would cause me less work? Create less work. Hammer?
Y equals x plus 3.
Yeah, y equals x plus 3. I'm thinking that's kind of a nice one. It's doesn't have anything that x is being multiplied by, so that's going to make it, a little bit easier. So what are we going to put in? Y equals negative 2 is going in for x. What is negative 2 plus 3, class?
1.
Negative 1 or 1?
Positive.
Positive 1. Y equals positive 1. There's our y solution. So our final answer Where would these cross on the graph had we graphed them? At ordered pair,
One,
negative 2, 1, yep, there we go. Okay. When they're in slope-intercept form, ditch the y's, set those expressions that have x in them equal to each other. You're always going to be solving for x first. Get your x value. Look back at your two equations that you started with and say, which one do I like better to put my x into? Put your x into it, get your y value. Presto, you'll have your x and y for your ordered pair. Any questions? Okay, let's go to the back. You need your books. Open to page 339, it looks like. Page 339, we're going to do the check it out problem. Number 3. You are going to do word problems in your homework today, so be engaged here. Don't let everybody else do your thinking. Okay, we're doing check it out number 3, so it's underneath example 3, just a little bit past halfway down the page. Would you read that? Just kind of a one long sentence there by 3. Read it to yourself, please. I don't know if you remember this or not, but last year, towards the end of the year, when we were working with systems of equations, we did application problems where we had to set up our own system of equations to help us problem solve. So that's what we're doing here. Take a quick glance at A. It says, in how many months will the cost be the same? What will that cost be? So that right there is saying to us, here's your two unknowns. In how many months will the cost be the same, and what will that cost be? So it sounds like we got to assign our x to something and our y to something. Anybody remember anything about independent and dependent? Anybody remember anything about independent variable and dependent variable? You can tell us something about it? Right? I'm sure if you haven't had it, there would be.
Isn't independent the one that depends on the dependent?
Independent. Rose? It's the variable that's alone.
And no, the dependent
The dependent variable depends upon the independent variable. So what variable do we typically make the dependent variable, right? Which variable, the x or the y?
No.
The y.
So
It was
it'd be
the
the
y.
same thing.
So the y is the dependent variable. That's what we typically give. We say, you know what, y, you're dependent upon what happens with x. X is the independent variable. So typically, remember, we had to have this kind of a thought process. Does how many, pieces of candy I get depend upon how much money I have to spend, or on how much money each piece of candy costs? What's independent? What's going to control the situation? How much candy I buy, or how much money I have? So we always have to kind of decipher, like, what's going to control what in a situation. So in this situation, we have these cable companies that they have a setup fee and they charge so much per month. What's going to control the cost? What's going to control the cost for this? How much money it's going to cost you to be with a certain cable company? Cameron? Per month? Did they tell us how much it is per month? I thought they told us that. They charge, one of them charges $80 a month and the other one charges
$40.
$70 a month?
Yeah.
We're on number 3 underneath, okay? I think you're up in the example, Isaac. We're in the check it out problem below.
Oh.
So maybe what we have to decide here is what we got to know. Total cost is going to be one of the unknowns. How much is it going to be? How much is your bill going to be totally? And the other unknown is how many months are you actually going to, have that bill? So what's gonna control what? Is the number of months gonna control the total cost? Or is the total cost gonna control the number of months? So
Months control.
yeah, how many months you have it, control how much it's gonna cost you in the end. Okay, so then we need to let X be the what? Number of months, yeah. Not the cost per month, but the number of months. We need to let that X represent how many months we're gonna have it. Then the Y, the dependent variable, is gonna be what? Total cost. We know how much the startup cost is. We know how much it is per month. What we don't know, what the number of months we have it is going to control is how much is it going to cost us altogether, the total cost. So we can't just put months and we can't just put cost. That's not enough information. The number of months and the total cost. That's important. Okay, let's set up an equation for one of the cable companies. What do you think would be an equation that would show us how much it's going to cost us if we go with that, one of the cable companies? Total cost, dependent upon the number of months. Pardon? If I'm asking for an equation, it doesn't matter which cable company you use, but we got two of them, so you pick one of them and do it. Stacy? 60 plus 80, yeah? Equation. What do you think, class? What's that over? What are the information in the book? Things that you can put together for the equation here for us? There's a one-time fee, it looks like it's $60. And 80 is being multiplied by X, so that tells me it must be $80 every month. And then she said it equals Y. She's saying if you add those two things together, you should get the total cost. You guys agree? Okay, then let's do the other one. What do you think the other one could be then? Ariel?
160 plus 70 equals
Okay, so 160 plus 70x equals Y. In other words, there must be a $160 startup cost, a one-time fee, and then this one is $70 per month. So can we all agree on we have a good system of equations here?
Yeah.
Okay. Does it matter that the Y is on the right instead of the left? No, it doesn't matter. They're still both equal to Y, aren't they? They're still both in-intercept form. Okay, why don't you do just the first step of what you think we're going to do to solve this? That's all I want you to do is write down, see if you look on the front side, see if that will help you. And we're going to work solving it. What's going to be our first step in solving? Okay, who wants to offer what they think would be a good starting place? Ian, what do you want us to do?
Subtract 70x.
Subtract the 70x from what? First step, I gotta go. I don't have anything to subtract 70x from right now, I don't think. Anyway.
You have to set up your equation as 160 plus 70x equals 60 plus 80x.
Okay, so 160 plus 70x, I think I heard, and set it equal to 60 plus 80x. Is that what you said?
Yes.
Okay. What do you think, class? Is that your first step? Remember step A today, when both of the equations are in slope-intercept form, we're going to ditch the y's, we're going to set the expressions that have the x's in them equal to each other. Does it matter which one's on which side? No. So if you set it up 60 plus 80x equals 160 plus 70x, you really have the same thing. It's okay. Now, so this is a good start. This is where we do want to start. Now we can go to work. What do you want to do for that first step, Ian?
Subtract 70x.
Subtract 70x from both sides. Okay, let's subtract 70x. Okay, now you guys are on your own. Solve for x, please. didn't put an A there. This is step A that we're actually doing, but I didn't put an A there because there's an A in the problem, and it might confuse us. So did you all get the same x value I did?
Yes.
X equals 10. Can we agree there? Okay. Well, what do we do now? Now that we know that x equals 10, maybe we'll circle that so we don't lose it. What should we do now? Brighton?
Put it back into one of the number equations and see if it works.
So, Brighton, I'm going to let you pick the equation you want us to use.
60 plus 80x.
Okay? So, does it matter which equation we use, class?
No.
No, you get to just decide. 60 plus 80x equals y. So, we're going to substitute into that equation. That's the one we're going to use. So 60 plus 80 times 10 equals y. Okay, do you agree with me that y is 860? Okay. So instead of writing an ordered pair answer this time, we know what these represent. If we had graphed this, the two lines for these would intersect at ordered pair 10, 860. Talk about a big y value this time. But instead, because we know what it's doing, we're going to actually answer number A, or letter A, which says, in how many months will the cost be the same? What will that cost be? So, in how many months will the cost be the same? In 10 months, the cost is the same, and that cost is, that's the other question, and what will that cost be? And that cost is what? $860. Remember us writing sentence answers? Okay, then we have letter B left here. Let's try to see if we can get through that pretty quickly. Well, that's like, you know what, if you're deciding which cable company to go with, if wherever you're going to set up this cable for is 10 months, let's say you're moving somewhere for a school year, and you say, you know what, we're going to move there in July, and then we're moving back out in May, so it doesn't really matter which cable company you go with, because when it's 10 months, it's the same cost. But what if you plan to move in 6 months, which is the cheaper option? So anybody have any idea what we could do to help us answer this? Because we don't have a graph to look at. Remember on the graph, we would look and we would see which line is below the other at 6 months, and then we'd be able to tell, right?
Can we use division?
Can we use division? How do you want to use division?
Yeah, that's what I'm asking. Could we use division?
Could, if we decide it's useful.
So what if we did it so that would be at 12 months and then divide by 2, which is 6.
So we figure out how much it is for 12 for each company and then divide by 2, because then it would be half a year. Okay, we could do that. Anybody think we could shorten that? Because how would we decide how much it is for 12 months straight? What would we do?
Check out.
We do, it's like we'd substitute in 12 for x, wouldn't we? And then in the end, we'd have to take our answer and divide by 2 because we really wanted when x is equal to what? 6. So what do you think we could do to make that shorter? Maybe not so much work for ourselves. Ariel, do you have an idea? Put 6 in for x. How about we put 6 in for x right away from the beginning? Okay, let's do that. Let's write down our 2 equations. We have our one that is, I can't remember them, 60 plus 80x equals y, and then we have 160 plus 70x equals we're checking to see which one's gonna be cheaper for 6 months. So that, we just decided that, well, we could not make this quite so hard, we could put 6 in for X into each equation and see what the cost is for that 6 months. So I really liked your idea, Trey. You had a great thought process going there. But do you see how we could shorten it? If you did them in the same order I did, I'm gonna call the one on the left the first one. How much did it cost the first one? $540. Okay, so this one is $540 for 6 months. And how about the other one? $580 for 6 months. And the question was what? Which one is cheaper? Okay, and explain. Well, our explanation's right here where you're showing your work. So we found out that, I won't make you write a sentence here, I'll put this one. Alright, I mean a really elaborate sentence. This one is cheaper. $40 cheaper, right? $40, $40. You know you're only gonna live somewhere for 6 months. Be a good consumer. Okay, questions about any part of that left you behind? Or you need to, if you need some clarification on something, you can get your hand up and Mrs. Creviston or I can come and help you. Okay, I'm gonna stop this.